Welcome back to my channel. In the series of learning programming in C, today in this video, I'm going to discuss about language translators. In the previous video, we discussed about the need of programming and the levels of programming. We learned about machine level language, assembly level language, and high level language. Those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all my new videos. And also please watch the previous videos for better understanding. The link is also given in the description. Well, what are language translators? Why do we need language translators? See, basically, computer can understand only one language, which is machine language. And if we write the program using machine language, that is using binary code zeros and ones, the machine can easily understand and it can be executed directly also. But we human cannot understand that, and it is very difficult for us to remember the binary codes. So what we can do? We can just switch over to assembly level language. Assembly level language uses mnemonic codes, different opcodes for different operations. So if I write these operational codes and if I create an assembly level language program, again the machine cannot understand these opcodes. So what do we require? We require a translators. The program that what we write is called as source code or source program. So if we write a program in assembly level language, we require a translator. We require a translator program. So which translator program do we require? We require a translator called as assembler. So assembler is the translator which translates the assembly level language program to machine level language, that is machine code, binary codes. So this is what the object code that what we are going to get. So we require a translator here. But we the user feel very difficult to remember these operational codes also. So what we do? We switch to the user friendly language, which is high level language. So in the high level language, when we write the coding, we use English like statements. It is very easy for us to remember, but again it is difficult for the machine to understand. So again we require a translator. So when we write the program in high level language, the translator that what we use is two translators. So when we create the source code using high level language, say for example I may use C or C++. See here I have written a program using C language and the file name is first.c. So when I submit this source code to the compiler, what the compiler is going to do? It is going to take the whole program. That is maybe 5 lines, 10 lines or 20 lines. The complete program will be taken. So after that, it is going to check for errors. So if there are any errors, it is going to display the errors. The compiler is going to display the errors. We the user have to resolve that errors. We need to save our program once again and recompile it. So once your program becomes free from errors, then it is going to translate your source code to object code, that is to the machine code zeros and ones. So in overall what I can say is the compiler is going to work in 3 modes. One is translation, then we have linking, loading, and then we do the execution with the exe file. So we do the translation, then we have linking the files, loading the files to the memory, and then the execution where we give different inputs and check with different outputs. So once this machine code is ready with us, which consists of zeros and ones, so it is sufficient if I load only this object code to the memory. So to the memory, if I just load this object code, it is sufficient. I need not load the compiler. I need not load the source code. So only the object code, if I load to the memory, it is sufficient, and then I can do the execution. So what I can say is the compiler is going to translate the source code before execution. So before execution, translation, that is conversion, is done. So as the compiler is going to do the whole program compilation, the compilation is fast. But once we compile the whole program, we get the errors at one stretch. So debugging is difficult. Debugging means, bugs means errors. Finding out the errors, resolving the errors is quite difficult. But compilation is fast. And one more point to say here, it requires extra memory to save the object code. Extra memory is required to save the object code. So this is what about the compiler. Let's talk about interpreter. So when we use the interpreter as the translator program, what happens? Let's see now. So we have the high-level language program, the source code. Say for example, I have the program written in C language, first.c. I'll give this first.c my source code to the interpreter. So what the interpreter will do? It takes the first line of the program. Then it is going to check for the errors. First line of the program. It will check for the errors. If there are any errors, it is going to display that error and we the user have to resolve that error. So once your program becomes free from errors, it is going to do the translation. So you are going to get the object code, the machine code which is in zeros and ones. Then once the machine code is ready, it is going to do the execution immediately. So it is going to run that particular line and you are going to get the output. Say if that first line consists of some input statement or output statement, it gets executed and I am going to get the output. Then what it will do? It will go to the next line. The next line will be taken and again I am going to check for the errors. If it is free from errors, do the translation. Object code, machine code is generated. Then immediately do the translation. So then I am going to run that line and I am going to get the output. So this is the process of interpreter. So in overall what I can say is the interpreter is going to run in one mode which is interpretation mode. So in the interpretation mode, what happens? While the program is running, while the program is executing or while the program is in running mode, it is going to do the interpretation work. It is going to do the translation and it is going to do the execution. So translation and execution will be done in parallel. So there is a parallel processing, translation and execution. So one more thing to tell here, no extra memory is required to store this object code. But one thing to tell you, once the object code is ready, immediately execution takes place and immediately I am going to get the output itself. So I need not require extra memory to save that object code. But when I say I want to do line by line interpretation, every time when I do the interpretation, I have to load the interpreter to the memory, I have to load the source code to the memory and then do the translation and execution. Whereas in compiler it is not like that. It is whole program compilation. Once the object code is ready with me, only the object code is sufficient to be loaded to the memory. I need not load the compiler, I need not load the source code. Once the object code is ready, only the object code can be loaded to the memory and I can do the execution. But here it's not like that. It is line by line interpretation. I have to fetch every line in my program, means I have to load the interpreter, I have to load the source code also. Then do the translation and then execution. So here it is taking more time. It is taking more time. So what I can say here, in the interpreter, the process of interpretation is very slow. But as it is a line by line interpretation, it is quite easy to debug the errors. So this is what about the interpreter. So hope you have understood the compiler and interpreter. The last thing that what I can say here is the compiler will be used by the high level languages like C, C++. Whereas the interpreter is used by Java, C# and Python. So well, this is all about for today's video. So let's see about the linking and loading process in the next video. Till then, bye bye, take care.